Geologist. Today's presentation is on Greenland Glaciology, and I'm happy to introduce Sasha Leidman. I hope I said your last name correctly. He's a graduate student in the Department of Geography at Rutgers University. So thank you so much, Sasha, for being here with us today, and enjoy.
All right, thanks for having me, everyone. So, as we can begin. My name is Sasha. I'm a PhD student at Rutgers University in the Geography department, and I study Greenland hydrology. So I've been to Greenland 7 times now for my research. But I'm also really into backpacking and whitewater kayaking. You can see me kayaking down the Grand Canyon there. My favorite glacier is the Gilkey Glacier in Juneau, Alaska. I got to spend the summer right near this glacier, camping out right above it. It was absolutely gorgeous. So my research studies meltwater streams flowing on top of the ice sheet in Greenland. So as the ice sheet melts, these streams form and they impact sea level rise. And my research looks at how that actually happens. I also do some other research on Greenland and throughout the polar regions. I help out with a research site higher up in Greenland where we do ice core drilling and look at how melt has changed throughout history. I also work in Juneau, like I said, where we were going and collecting water samples underneath glaciers in the ice cave there we got to explore. And I've also worked in Antarctica. I spent the summer there a few years ago, camping out on an area called the McMurdo Dry Valleys. And we were looking at these ice-covered lakes, and we were drilling into them and collecting samples of dirt, as well as scuba diving into them to pick up samples of microbial mats. I've worked in Denali National Park. I worked for the National Park Service there as a junior park geologist, where we were studying how much the glaciers in Denali National Park were melting. This is me on Kahiltna Glacier, which is really gorgeous. And I started my science career working in California. I'm from California originally. So we were studying streams and rivers throughout the northwest of California and seeing how much sediment and dirt was moving through them so that we could have a better understanding how fish and the buildup of sediment behind dams might be impacted. So I mentioned that I study the Greenland ice sheet, but what is an ice sheet? To put it simply, an ice sheet is just a really big block of ice. So a section of ice that's so big that it covers an entire country or continent. So we only have 2 of those, one being the Greenland ice sheet in the northern hemisphere, and the other being the Antarctic ice sheet in the southern hemisphere. So how do these ice sheets form? So they form from snowfall. As snow builds up year after year and doesn't melt away, these ice sheets can grow bigger and bigger until the point that they get so big and thick that they deform, they move under their own gravity. They get so big. This ice builds up and it starts to flow out to the ocean. So how big is it actually? So the Greenland ice sheet is 2.9 million cubic kilometers. So it's really hard to put into perspective, but hopefully this kind of gives you an idea. If every person on the planet, all 7-point-some billion people, were to fill up a glass of ice every second, it would take 25 years to equal the same amount of ice as the Greenland ice sheet. There's a truly gigantic amount of ice in Greenland. That equates to roughly 21 feet of sea level rise. If everything was to melt, the sea level would rise 21 feet, which would be really tragic and we don't want to happen. You can see what San Francisco would look like if 21 feet of sea level rise, as well as Los Angeles and Miami, which would be completely underwater. So I study superglacial streams. These are streams on top of the ice sheet. And so as the ice melts during the summer, the melt accumulates into these streams, and they drain off the surface of the glacier through these networks of rivers. And so these rivers are really important because they're significantly darker than the rest of the ice. So the normal glacier reflects about half of the sunlight that hits the surface of the glacier. And that sunlight doesn't go to melting the ice, but instead gets reflected back into space. But these streams, instead, they absorb about 80% of the light that hits them. They're this kind of darker blue color, and so they can absorb more of that light and contribute more to melting. Additionally, these streams tend to consolidate dirt and sediment within them. As wind blows dirt onto the surface, these streams melt away at it, and they consolidate it into these large floodplains. And that sediment has an additional absorption of sunlight, so it melts it even more. So knowing where these streams are is really important for knowing how much sunlight is available to melt these glaciers. So here is a video from my fieldwork. And you can see we study streams just like this one. We fly drones over these streams in order to map them and make 3D models of these streams. And then we take measurements such as how much water is flowing through the streams. We take sediment samples, all to measure the hydrology, the river flow through this system. You can see that they're really quite gorgeous. You get to hike up from the tundra up onto these glaciers and spend all day taking measurements in these beautiful locations and wading through these ice cold streams. This is me walking down one of these streams. It's kind of a crazy view with a 360 camera. But what I do for my research is I collect GPS measurements all along the stream bed, over 10,000 measurements per stream. And then we use that data along with the flow data and the velocity data for these streams in order to put them into a hydrologic model. And that way we're making this kind of fake system that we can run in the computer to test out different scenarios of how these streams are going to function. And we can use the drone data for that as well. So you can see the streams that we just flew over. That's the top one is that imagery, and that you can see that gorgeous blue color that it has. And we can use that imagery to find out where all the sediment is in order to figure out what that absorption of sunlight is, when we know the difference between how much sediment there is versus how much bare ice there is. And then we use that GPS measurements in order to figure out what the water depth is. And that allows us to input that into the models. And so what these models look like is that we can use these GPS profiles in order to flow water through them. And that way we can tell how much surface area these streams have and how much ability they have to move and flush out the sediment, the dirt. And so these models are really useful for being able to determine how dark the ice sheet is and how much water is going to be flowing out into the ocean. So these models have been used all over Greenland. And you can see that the darkness of the Greenland ice sheet is slowly but surely getting more and more dark. That red means that it's getting darker as more sediment builds up on the ice sheet, as well as more melting occurs. The actual snow gets darker. And so this is going to be an increasing problem as more and more melting occurs. Why should we care about this? So Greenland is rapidly melting. So entire fjords that were filled with gigantic glaciers, as you can see here, have now completely melted away. And all that ice ends up going into the ocean and leading to sea level rise. You can see here a picture that was taken just this past year of an area that's normally completely covered in sea ice, but now that sea ice is completely flooded, and these dogs are walking on top of it. And it's a really crazy sight to see how much change is happening and how the people that are living there are going to have to drastically change their way of life. So how much is it actually melting? Well, the great thing about science is that we can quantify this and figure out a number as to how much ice is actually making it to the ocean. And it turns out that Greenland is melting at 281 billion tons of ice per year. And that's hard to imagine, but that equates to every single person on the planet filling up, getting 2.5 ice cubes every second. You can imagine if you were to fill your glass with ice, if every single person in the planet did that, that would be how much ice is being lost from the Greenland ice sheet. So it's a truly staggering amount. So much ice is being lost, but it's actually changing the deformation, the shape of the Earth. It's pretty crazy. And this is leading to sea level rise as we contribute more and more to climate change and we put more carbon into the atmosphere, more ice is going to be melting from the Greenland ice sheet. You can see a time lapse here. 6 degrees melting is kind of the rate that we're at right now if we don't do anything to address climate change. If that's the case, then the Greenland ice sheet might melt away in 5,000 years and might be leading to over a meter of sea level rise in only a few hundred years. So it's a truly dramatic change to see an entire continent experiencing melting like this. So what can we do? The important thing to realize is that it is never too late to fight climate change. The sooner we do something, the better off we're going to be. And the more significant our actions are, the safer we're going to be. But it's never too late. So the most important steps you can take, if you're over 18, please vote for candidates that believe in climate change and want to address it, put in policies like a carbon tax. If you're not old enough to vote, then ask your parents who they're voting for, or ask your friends and see if you can convince them that this is an important issue, because talking about climate change is one of the most important things we can do, making sure that people know that you care about this issue. Also, you can reduce your own carbon footprint. Things like eating less meat or driving less or using less plane flights are really important for reducing your own carbon footprint, but we really need like a government-wide policy in order to really address this problem. The last thing is making sure you put your money in the right place. So spend it on companies that are responsible and have a low carbon footprint, and donate to charities whenever you can, so that we can push for solving this problem. So that's about it. I'll take some time to answer some of your questions. I'm sure we've already gotten some, and I'm happy to answer any. So if you have any questions about my research or climate change or Greenland or anything like that, I think we'll go from here. Let me just get out of sharing it. All right. Can you still see me?
Yep, we can still see you.
Okay. Pull up the questions here. All right. So Christopher Reed from Newark would like to know, glaciers melting is a sign of climate change. How can we prevent the polar bear population from decreasing? And that's a good question. So there are not a lot of polar bears, and the polar bears that we do see are really struggling. So a lot of them are moving south into environments that they're not used to, and having to compete for territory with grizzly bears. And it's not a great situation. The most important thing we can do is try to save their habitat. So polar bears live on sea ice, and the Arctic sea ice is expected to go potentially completely melt away during the summers by 2050. And so if that happens, they'll have no place to live, and they'll have to completely adapt to a new lifestyle. And so reducing the amount of carbon we put into the atmosphere and doing things to make sure that there's more sea ice are really important for making sure that polar bears still are around for as long as we can. All right. So Mary from Scott Plains asked a few questions. I can answer some of them. So let's see. Are there ice sheets extending off the coast, like in Antarctica? There are. We have a special name for ice sheets like that. They're called ice shelves. So a lot of glaciers don't just flow and end on land; they end in the ocean. Those are tidewater glaciers because they hit the tides, and they're really important because they not only melt from the sunlight hitting them and melting them, but they also melt because of the ocean temperature increasing. As we increase climate change, the ocean temperature rises, and the ends of these glaciers melt away. And so they can be incredibly fast at melting compared to other glaciers. All right. Let's see. Maybe we'll take one more question from Mary. So let's say, what do native people or indigenous people think about changes in glaciers, and how does it affect their lives? So I've had the privilege of working with a few indigenous people in Greenland, as well as Alaskan natives, and they are incredibly important to our research process. They're the ones that know these glaciers much more than we do, and the indigenous knowledge that they hold can lead to some really important insights about how these glaciers are changing. The changes to these glaciers have a big impact on their daily lives. A lot of the individuals that live in Greenland and in some places in Alaska don't have any form of roads or traditional forms of transportation. And so as sea ice melts, then they kind of lose their road network, and they can't travel with sled dogs or snowmobiles out on the sea ice, and they can't visit relatives, and they can't hunt for food. A lot of these people, the food is extremely expensive in grocery stores, and so they hunt a lot for their food. And if the sea ice is gone, just like for polar bears, people can't hunt as easily, and it really makes it an even worse food desert than it already is. So it's a really serious thing, and you'll see a lot of indigenous people are incredible activists on climate change and are fighting to make sure that we do something about this. All right. Next question. All right. I don't know who asked this, but one person asked, why is the Gilkey your favorite glacier? It's a great question. The Gilkey is an absolutely beautiful glacier. It's experiencing a lot of melting, One of the things that makes it so beautiful is that it has something called ogives, which is a really cool word, but it's used yearly lines, striations across it of dark ice, light ice, dark ice, light ice. And that's formed as the glacier moves over an ice fall, an ice waterfall. And as it moves during the summer, it builds up more sediment and melts more. And so that ice is darker. And then during the winter, the ice that flows is lighter in color. You have these beautiful bands all the way down the glacier. Also, our camp was right on this beautiful area that we call a nunatak. It's just an island of rock in the middle of the glacier. And so we could just sit out on the rock and see the glacier, and you could hear the glacier cracking as it moves. It's a really powerful place to be in. So we had a few questions about glacial lakes. So what are glacier lakes? What are the different names for them? So my research is mainly on superglacial streams. So those are rivers forming on top of the glacier, but also lakes form on top of glaciers. Some of these lakes can be gigantic. They can be tens of miles across in some instances. And they're really important, just like streams, because they're increasing the amount of sunlight that's absorbed by the glacier, but also because they can rapidly drain. So as these lakes develop, they're a pretty big weight on the glacier, and that weight can cause the glacier to crack underneath the lake. And if that happens, all that water suddenly drains into the bottom of the glacier. And that can be really dramatic for kind of lubricating the bottom, making it easier to flow, and increasing the amount of ice that is moved towards the ocean. So there's a lot of researchers currently looking at glacier lakes and seeing how they might change and how it might go even further up onto the ice sheet. I feel like I'm giving like certain people like preference by answering their questions, but I want to answer everyone. So Ria's mom would like to know what kind of effects do pipelines and oil drilling have on glaciers in Alaska? And what are the concentrations of carbon dioxide and methane gases in the Greenland ice sheet? And so when we're talking about oil drilling, the most important thing is that the more oil that we extract, the more oil that we use, the more carbon dioxide makes it into our atmosphere. It's kind of a scientific understanding that a safe amount of carbon dioxide in our atmosphere is around 350 parts per million. And currently, we're on track to be over 420 parts per million right now. And that number will likely increase. And so we're in very dangerous territory right now. And so the more we drill, the more these ice sheets and glaciers are going to be melting. And you see just incredibly dramatic. I've seen it with my own eyes of how much these glaciers are receding. But also in the Arctic, you have an additional problem. There's a lot of oil drilling, and especially now that the Arctic sea ice is melting and more companies can reach the Arctic Ocean on a more regular basis, there's a potential for more drilling to happen in the Arctic Ocean. And that's a really scary prospect. For one, a lot of people rely on the sea life that's there for their food source. And if there's an oil spill, we really don't know how catastrophic that will be for the sea life, and it could completely destroy these ecosystems and the food source for these people. And really, we've never really developed a way of cleaning up an oil spill in an area that has sea ice. And if there was an oil spill, it would be completely devastating, and it would take probably years and years to actually clean up. And so I urge anyone to reconsider if they're thinking about promoting an increase of pipelines or drilling in the Arctic. Yes, there was an oil spill. It's actually, I think it was a natural gas leak in Siberia, and so that's definitely something that's really, really tragic. And so, yeah, the additional thing is that when you have oil spills in the Arctic, a lot of times, if you're not doing open water drilling, you're drilling in tundra and on frozen permafrost, and so that has an additional effect of if you're burning that off to deal with the spill, and you're also melting that permafrost and releasing an additional amount of methane as a result. So yeah, there's just a lot of compacting factors that can really be bad in that situation. Cool. So Tracy wanted to know, I once tried to book a trip to Greenland and couldn't make it happen. How do you get there? It's a great question. Right now, we are not. So all of our fieldwork for the season was canceled due to COVID-19. And we are not allowed to go for our next season in September. We're really concerned about spreading the disease there. And so a lot of these communities don't even have a hospital or any medical care. And so spreading the disease there would be very catastrophic for these communities. How we normally get there is we fly with the Air National Guard. So there's the Air National Guard in the US flies from Albany, and we fly directly from Greenland. But Greenland is a country just like any other. And once COVID-19 is no longer as big of a problem, you can just fly there. You can fly directly from Iceland or from Europe. There are no flights directly from the US. So it's a bit of a long journey, but yeah, I definitely recommend it. It's a gorgeous country with a very rich culture, and it will be worth your while. All right. I don't know how many I still have time to answer, but let's see.
You're good on time, so you can answer what's there.
Okay. All right. So how much will sea level rise if all of the ice in Greenland melts? A two-part answer there. For one, we don't expect Greenland to melt entirely. And so with the melting that occurs right now, there's so much ice in Greenland. There's an equivalent of 7 meters of ice, 21 feet of ice in Greenland, or 21 feet of sea level rise equivalent in Greenland. And so if all that melted, it would be really catastrophic. We don't expect that to happen for several thousand years if it does happen. But still, even if it doesn't melt completely, in our lifetimes, it can still significantly increase sea level rise. So estimates for what the sea level rise will be as a what we call business as usual scenario of us just continuing the amount of emissions of carbon dioxide that we have right now, are that sea level will rise as a result of Greenland melting by over a meter, over 3 feet, 3.5 feet. And so that would just be really bad. And that does not factor in the fact that sea level rise would result from melting of mountain glaciers in Antarctica as well. And so if that was to happen and we don't do anything about climate change, you would have an incredible increase in the damage from hurricanes, from flooding, and you would have entire coastal communities that are completely flooded on a daily basis. And so we already see that we have climate refugees in the U.S., in the Alaskan coastline, as well as in Louisiana. There's communities that are already been flooded out, and that's only going to get worse. And the amount of sea level rise that results if we take drastic action on climate change is significantly less. And so it would save millions of lives and homes. Yeah, sorry to be bleak about this. Maybe the important message to take away is that you can do something about it. And there's still actions that we can take. David Letcher would like to know, has the number of icebergs been increasing in the North Atlantic due to the melting of the Greenland ice cap? Kind of. There are projects that are looking at tracking every single iceberg coming from Greenland, which is pretty crazy because there's literally millions of them. But while the Greenland ice sheet is producing more icebergs as it flows faster out to the ocean, it's also melting those icebergs faster. The ocean is warmer, and it's exposed to more warmer air as well. And so those icebergs melt away much faster. And so the amount of icebergs is not changing that much, and might actually be decreasing because of that melting. All right. Carol Drews would like to know, what other animals are being affected? I don't know if there's a single animal on this planet that is not affected in some way by climate change. There are animals that are significantly impacted more than others to climate change. You see all around the world that animals are migrating north and into deeper waters. And as they do that, they oftentimes have less habitat that they can occupy, and there's more competition for animals. In Greenland, we have some beautiful, we call megafauna. We have muskox and caribou, reindeer, and Arctic hare, and they're all trying to figure out how to deal with these changing conditions. They're used to very long snowy season, and going into hibernation in some cases, and so their populations are dropping in some cases. We see some of the biggest changes in population in marine ecosystems. Fish like Arctic char around Greenland are really impacted by changes in sea temperature. And so, it causes changes in fisheries and changes to access to the amount of fish available. So, there's huge impacts to animal life throughout the world. So how cold is it in Greenland? Cold, very cold. And in our primary site in Greenland, surprisingly warm. It's kind of sheltered from a lot of weather due to mountains all around it. And so we can get days that it's actually up to 50 degrees in the peak high temperatures. in the summertime. Normally it's around freezing temperature in the summer. But for our site that's higher up on the ice sheet, it's significantly colder. We had days that it got down to, I think our coldest was negative 34 degrees Celsius, which is around negative 34 degrees Fahrenheit. And very windy. The winds can be up to 50 knots and can completely blow down tents. We actually had one of our tents just completely demolished by the severe winds. And all you can really do is kind of hunker down in your most stable tent and hope for the best. But yeah, it gets very cold. Winter temperatures can get down to negative 55, negative 60 in the worst cases. And so it's a very cold place. But that saying, it's beautiful in the summer, especially along the coasts. And it can be a really dramatic and beautiful change from season to season. All right. I guess that leads to what do you wear to protect yourself from the cold? We wear a lot of clothes. In the summer location that we work out of, mainly you can work in just whatever winter clothes that you would normally wear around New Jersey. But higher up on the ice sheet, we wear a lot of insulated clothing, down jackets, and insulated pants, these really thick mountaineering boots. And we always have to have our face covered, especially if it's windy. There's a lot of UV light there, and it's really easy to get frostbite or sunburn at the same time. It's really, really awful to get frostbite and a sunburn at the same time, but it's possible. And so, yeah, we have to make sure that we're covering ourselves and making sure that we don't get hypothermia or frostbite. Most days that we're out there, it's not as bad. It can be around negative 10 degrees Celsius, and you can just wear like a really thick down jacket and some gloves, and you're off to a good start. But some days it gets really cold, and you have to really bundle up. All right. Why did you decide to study glacial hydrology? It's a great question. And I think every scientist has their own story as to how they got into the field that they are studying. I originally wanted to be a hydrologist. I loved kayaking and whitewater rafting and did it all over California, and was a rafting guide for several years. And so I love rivers, and worked at the Center for Watershed Sciences at UC Davis. And then in college, I went to Juneau with the Juneau Ice Field Research Program. And they have a glaciology school out on the Juneau Ice Field. And I was lucky enough to get a scholarship to go out there, and it was amazing. It was really eye-opening how gorgeous these landscapes were. I truly believe that there's no landscape that is more aesthetically pleasing, attractive as a glaciated landscape. And if you ever have a chance to see a glacier, I highly recommend it. It'll blow your socks off. And I was fortunate enough to actually go back to Juneau and as a faculty member and teach their school. And so I've been hooked ever since. I went to Juneau and wanted to study glaciers ever since. Cool. Which place did you like better, Greenland or Alaska? Ooh, man, you're making me choose between my children here. So I don't know. I mean, I've devoted most of my research career to Greenland. So that's got to say something. Greenland is just not like any other place. It's just so gigantic, and the glaciers are just endless. And the food is amazing. And not that Alaskan food is not amazing too. You definitely try some Alaskan salmon. But yeah, the fact that it's so remote and so untouched is definitely something that really draws me to Greenland. All right. Where would you go if you could go any place in the world to study ice? I mean, Greenland, Antarctica, and Alaska are pretty great places to study ice. I've been to New Zealand as well, and they had some beautiful glaciers as well. I'd love to. I think the one place that I haven't really been to that I think deserves more of my attention is some Himalayan glaciers, and looking into some of the glaciers around Mount Everest and Tibet and that area. And there's some really cool glaciers that don't get the attention that they deserve. There's a lot of climate change happening in those regions, and so despite the fact that mountain glaciers only make up a tiny fraction of the amount of ice on the planet, they're still contributing about the same amount as what Greenland and Antarctica are contributing right now, just because they're melting so fast. And so that won't last long, and we're going to have mountain glaciers that are disappearing, and we already have. And so I'd definitely like to go out and study some Himalayan glaciers before they're all gone. All right. Let's see I think I've missed a few.
I think you have time for one more.
Okay.
We have one left.
Gotta make it a good one then. So Mary asked a few questions about the North American ice sheet and evidence of that in Long Island, and how that relates to the current changes of Greenland right now. So yeah, it's really cool to think about the fact that during the last ice age, all of the North American northern part was covered in ice. It was an ice sheet called the Laurentide ice sheet. And that ice sheet pretty much covered all of Canada, and it came all the way down to Long Island, New York. And you can still see that there's two very prominent moraines, or these linear sediment features all along Long Island that formed it. And you can see evidence of glaciation in Central Park. There's bedrock that's exposed there that have what we call glacier striations, or kind of scars from sediment moving on the bottom of the glacier. And so, yeah, Greenland ice sheet was connected to that ice sheet only a few million years ago. And so all of that ice melting away had rose sea level a lot. And it also what's caused New Jersey to be some of the fastest rates of sea level rise in the entire world, as the crust actually rebounds from the weight of that ice sheet being lost. New Jersey is actually sinking, subsiding into the earth. So that's compounding the effect of sea level rise. So yeah, I guess the takeaway is thanks everyone for watching and for showing interest in climate change and Greenland. I encourage you all to look into some beautiful sites in Greenland and visit a glacier if you ever have a chance, and to talk to your friends about climate change and figure out ways that you can potentially help out in this effort to fighting it. Thank you.
Great. Thank you, Sasha. That was very interesting and eye-opening. So thank you for spending your time with us this morning. And to all of our attendees, thank you for watching. Just be sure to tune in next Tuesday. We have Dr. David Robinson. He'll be talking about the role of snow in the climate system. And I apologize, my puppy's barking in the background. It's lunchtime for her. So, and it's lunchtime for all of us. So thank you, everyone, and have a good weekend. We'll see you next week. Thank you, Sasha.
Bye.